So let's start with our first subtopic, number system. Let us skip to the first question. If a and b are integers and a minus b is an even number, then which of the following must always be even? We have options as ab, a square plus b square plus 1, a square plus b plus 1 and ab minus b. Now let's jump to the solution of this question. First, let us solve this problem using an example. Let us divide this problem into three cases, where in first case we take a as an even number and b also as an even number. In second case we will take a as an odd number and b as an odd number as well. And in third case we will take either of a and b as an odd number and the other one as an even number. So let us begin with the first case, where we are assuming both a and b as even numbers. So let us suppose a is equals to 8 and b is equals to 6. So we can derive that a minus b is 8 minus 6 equals to 2, which is an even number. Now let's check the options. ab is 8 into 6 equals to 48, which is even. This is even. Then a square plus b square plus 1, that is 8 square plus 6 square plus 1, 64 plus 36 plus 1 is 101, which is again an odd number. Then we have a square plus b plus 1, which is 64 plus 6 plus 1 is equals to 71, which is again an odd number. Then we have here ab minus b, which is equals to 8 into 6 minus 6, which is 48 minus 6 equals to 42, which is even. So in first case we have got even numbers in just two cases, in ab and ab minus b. Now let's move on to check the other cases and check these options, in which of the options we get even numbers. So now let's move to case 2 of our problem, where we are assuming that both a and b are odd numbers. Let us say a is 7 and b is 5. So here we compute a minus b as 7 minus 5 equals to 2, which is even. According to our question, a minus b is even. Now we can again compute that ab is equals to 7 into 5, which is 35, which is again odd, and a square plus b square plus 1 is 7 square plus 5 square plus 1, which is equals to 75, which is again odd. And a square plus b plus 1, which is 49 plus 5 plus 1, which is 55, which is again odd. And here we have ab minus b, which is 7 into 5 minus 5, that is 35 minus 5, which is equals to 30, which is the only even term here in case 2. Now in case 1 we had even terms in two computations, but in case 2 we have even term in only one computation. So we need to take the intersection of both these cases, and we will be seeing that only ab minus b gives even number in both the cases. Now we have already got our answer that ab minus b is the only number which is the only form which gives an even number, but we will still explore the case 3 for the convenience of the students to understand the problem and the proof. As we have already said that we got our answer from computations of case 1 and case 2, but we will still be showing case 3 for the convenience of the students so that they can visualize the problem in a better way. In case 3, we will be assuming one of a and b as even and the other number as odd. Let us suppose a is 8, which is an even number, and b is odd, which is 5, which is an odd number. So here we can see that a minus b, that is an even number minus an odd number, or any odd number minus an even number, always gives an odd number, which is 3 here. But in the problem we have been told that a minus b should be even. So this case is not valid in this problem. Only case 1 and case 2 are valid, where a minus b is an even number. So we can conclude that our right option is ab minus b, which we got from computations of case 1 and case 2, since the intersection of case 1 and case 2 gives us this option. Thank you. So that's how we can solve the given problem. If you have any doubts, suggestions or any better ways to solve the problem, please do comment down, and don't forget to like and share this video and subscribe to our channel.